Sir, are you speaking to us? Your mic is mute. We're not hearing.
Okay, sorry about that, guys. So I'm here babbling away and you guys are not hearing me. All right, so let me just repeat what I was saying. So as I was saying, once we reach this step, it would have been clear that our first term and last term are written in a square form. And this would have indicated to us that we have a perfect square. Now, it indicates, but we are not fully sure until when we check the middle term. So if the first term and last term can be written in a square form, then possibly we know we have a perfect square. In order to confirm that, though, we need to check the middle term. Now, to check the middle term, we have to go back to the property of what the perfect square would be for the middle term. So remember that the middle term would have been twice the base of the first and the base of the last. Now, when we look at this expression, what would be the base of the first term here? Ms. Cavero.
Sir, the question, please.
What would be the base of the first term?
(3A).
All right, very much so. Anybody else agree with Ms. Cabrera? Let me see your hand. All right, so what would be the base of the last term now, Ms. Cox?
Sir, B.
The last term. The base of the last term.
2B, sir?
Yes, 2B, because once you have that bracket around it, it means that everything in the bracket is raised to the power 2. So the base is what really in the bracket. Clear about that now, Ms. Cox? All right, so
yes,
so we say that the property for the perfect square is that the middle term has to be 2 times the base of the first times the base of the last. So what would this give us, Ms. Waysom, if we were to multiply 2 times the base of the first and the base of the last?
Sir?
Yes.
2 times 2, the base, 2 times the base of the first would be 2 times 3.
All right.
Times the base of the last.
Not just 3, Ms. Waysom.
3A, yes.
3A times?
Times the base of the last, which is 2B.
All right, then multiplying out this now, we'll get what?
Give us 12AB.
All right. Now, this is what we check to see if it corresponds with the middle term. And once this is corresponding with the middle term, then that's what we need to confirm that we have a perfect square. So here, when we multiply the base of the first and the base of the last, and we times it by 2, we see that we get 12AB, which is the same thing we have in the middle. And so once that is so, it means that we can say for sure now that we do have a perfect square. And once we identify this now as a perfect square, then the next step now is just to apply the technique of factorizing. All right, so if we are to apply that technique of factorizing, what would be the way how to factorize this? Ms. Cox, how do we factorize this now? All right, Miss Clark, how do we factorize once we identify that this is a perfect square? How do we go about factorizing it?
Okay, sir, what you need to do is put the base of the first term And the last term, which is 3A and 2B. So it is 3A.
So we put the 3A.
Yes,
It's
sir.
just the base we are working with now, just the base. So we put the 3A and
2B. Yes,
in
sir.
the brackets. And now between them, we're going to put the what?
The plus sign.
The sign of the middle term. The sign of the middle term.
Yes, sir.
And this is the middle term. Whatever sign the middle term has, we put it between the two terms in the brackets. And then what next now, Miss Clark?
We put the square up, the two up there, so
the square outside.
All squares. Yes, sir.
And that is the process of, I would consider it to be a shortcut process. So once you get those bases in bracket, put the plus sign in, or the sign of the middle term between it and the square outside, then that would be your complete factorization. So the factors then would be what? 3A plus B, 3A plus 2B, all square. And that would really mean what? 3A plus 2B times 3A plus 2B. And those are the factors. All right. Any question so far? Let me see your hand if you understand what I'm saying. All right. So I see some persons are still reluctant to respond. So the general process is we first rewrite the terms, the first term and the last term in square form where possible. And then we now write the last term in square form, and then we check the middle term now by multiplying the base of the first times the base of the last times 2. And then we get the middle term, then that confirms that we have a perfect square. Next, we just factorize that now by just simply bringing down the bases in brackets, and then we put the sign of the middle term in between them and the 2 on the outside. So that's the process of how to quickly factorize these. Now, just recall that I mentioned that it can also be factorized by what? The AC method. And just to give you a sense of how this would be done. Now, what would be AC in this case, guys?
9A squared and 4B squared, sir.
Now, AC from the quadratic form, A would be the coefficient of the first variable. But remember, the last term, C, would be everything here. So AC would be 9 times 4B squared, right? 4 9s give you what?
36.
36.
36 what?
B squared.
Right. So now what we want to do is to find 2 factors of 36B squared. When we add them, we get 12AB.
Sir, it would be 36AB.
No, the coefficient of the middle term now. No, man, the AB is not in it, because remember now, the variable here is A squared and A. Remember when we're doing the other form, this would be like the X squared and this would be the X. And so when we're looking for the coefficient of the middle term, we really want the 12B without the A. So we want 2 factors of 36B squared. 2 factors. That would give us, when we add them, we get 12B. So what 2 numbers that you multiply to get 36? And when you add them, you can get 12.
6 times 6, sir.
Huh?
6, sir.
All right, so 6 times 6, right? Now, so we could write this as 6b times 6b. So you see, when we multiply 6b times 6b, we get 36b. But when we add them, what we would get?
12.
All right, so it means that we would have replaced the middle term with the, so we'll have 9a. So let me just clear these and show you what it would work out to be. So we would have the 9a squared plus 6b, 6ab, because remember we have to write back the, it would have been x, but now in this case we have to write back the a beside it. So we know the two factors would be 6b, but we put back the a beside it. So we'd have what? 6ab plus 6ab plus 4b squared. All right, so if we factorize by grouping, what is common for the first pair? Guys, what would be common?
6, sir.
Is it 3A?
3a. So we factorize the first pair by 3a. 3 into 9a squared give you what?
3A.
3a. And then now 3a into 6ab give you what?
2B.
2b. And then now for the other pair, what would be the common factor?
2.
All right, so we could use not just 2, but what?
2B. Sorry.
2b. So 2b into 6ab give you what?
3A.
3A.
And 2b into 4b squared.
2B.
2B.
2b. And if we are to look at the bracketed expression, they are common, so we pull out the bracket. So we have 3a plus 2b. All right, then we group what is outside now in another bracket, which would also give us what? 3a plus 2b. Everybody see that? Which is the same as what? 3a plus 2b all square. Everybody see that? Because 3a plus 2b times 3a plus 2b, you're multiplying it by itself. Everybody see how we get it by AC method?
Yes, sir.
But what you would have noticed here, the AC method would have been so much longer. Do you agree?
Yes, sir.
Right. So instead of going through this long process for perfect square, we just simply identify the properties and then bring down the basis of the square in brackets. And then we square outside. All right, so everybody get the idea? Let me see your hands if you all get the idea why we are using the shortcut method. All right, good enough. All right, so if we want to check, we could easily multiply out the 3a plus 2b, we expand it back and we should get what we started off with, which is the 9a squared plus 12ab plus 4b squared. All right, now, so that is the process of factorizing perfect square. Now we're looking at difference of squares, or difference of two squares. Now, the definition for this, when we have one square term minusing another square term, then we call this a difference of square. Example, we have a square minus b square. So this is pretty much a difference of square. Now, if we are factorizing this expression, then it works with a formula. Now, when we actually combine these two factors and multiply them out, now, if we multiply out these two factors, a squared, a times a, we get a squared. And then now we would get what? What would be the next one? A times what? Come guys. A times minus b. What we get?
Minus AB, sir.
All right, so we'll get minus AB. All right, so we'll have minus AB. I'm sorry, it should be written in capital letter. Give me a second, guys. All right, so as I was saying, guys, so we have a squared minus AB. So we have AB. And now we have now A times, sorry, not A, but we have B times A, which is the same as what? AB. So this one now is a plus AB. All right, so now we have plus AB, then we go now B times B, but this is positive A times minus B, so that's going to give you a minus B squared. Now, what you notice about the middle terms, these are like terms, but what you notice about the signs? Miss Waysom?
Sir, can you repeat? You were breaking up.
I was saying that what you notice about the middle terms in this expansion.
Both terms will be eliminated, sir, because we have them at the same value, but one is negative and one positive. So negative from positive will just eliminate it.
All right, so there are same like terms, but one is positive and one is negative.
And one is negative.
So if you take away a number from itself, it will leave you with 0. So when you have a positive and a negative of the same term, when you add them, you get 0. So if this becomes 0, then what is it that we are left with?
We'll be left with A squared minus B squared, sir.
All right. So it means then all that we are left with after we have Let me put back this. All that we have left with here now, the middle term becomes 0, so we are only left with a squared minus b squared. Now, because this is the expanded form of these two factors, then clearly we could write that a squared minus b squared is equal to the product of these two factors, a plus b, times a minus b. Because when we multiply these two, that's what we get, a squared minus b squared. Everybody see that? Let me see your hand if you are following me and you're in agreement with what I'm saying. All right, good. Now, since this is so, if this is the expanded form, then the right-hand side is the factorized form. So all we have to do is just remember this formula. So what would be the formula? If you have a squared minus b squared, then it is equal to the product of a plus b times a minus b. So that's all you need to remember. And so all of this is treated as a formula. And if we're treating this as a formula, it means that once we see the difference of square, we can write the difference in the form of this product, right? And that's how we generally factorize difference of square. We just simply write the difference as the product of the sum of the base of the two terms. So let us look at what that means. Now, what is the base of a squared?
A, sir.
And what is the base of b squared?
B.
All right, so what you notice, the brackets, we have the bases. So we have the two bases in the bracket, but one carries a plus sign and the other carries a minus sign. So if you can remember that, then you shouldn't have any problem in factorizing difference of squares. All right, so let us follow what this is saying now. And then now, when we're factorizing any difference of square in this form, we simply use this formula. And so the expanded form is the a squared minus b squared. And the factorized form is a plus b times a minus b. Let us see how this works with an example. Now, when we see an expression, it's not going to obviously be in its square form. So, but we have to look at the numbers in front of the squares and see whether or not they can be written in a square form. So we notice that 9 can be written as what? Can be written in the square form as b squared. 16 can be written in the square form of 4 squared. And so we would rewrite these numbers in their square form. And then after we have done that now, instead of loosely squaring each of these, we just bracket this 3a, bracket the base of 3, and the base of a. And then we put 1 square outside. Same thing we do with the other form. Bracket the base of the 4, the base 4, and then we bracket it with the x. And then we put 1 square. Now it is clearer that we have a difference of square. Now that we have it in this form now, next what we need to do is to factorize it. How we say that we factorize this now, Ms. Waysom?
Sir?
Yes.
Repeat, sir.
How do we go about factorizing this?
Take out the base, sir.
And do what with the base?
So first we're going to open a bracket. We'll bring down the base, which is 3A.
All right, so generally I would like to say open two brackets. Put the bases them in both brackets. So you put the 3A.
Yes, sir.
And then you put the what? What else are you going to put in this bracket?
4X, sir.
All right, so we put the 3A. And remember now, we're going to leave a space between them so that we can put in the sign. So we put in the 3A, then we put in the
4X.
4X.
Yes, sir.
That's for both brackets.
Go again, sir.
So we just do that for both brackets, put in the B.
Yes, sir.
So we have the 3A, then the 4X. And once you put in those bases, all that we need to do now is to put a plus sign in one of the brackets and a minus sign in the next one. So this one is a plus, and this one is a minus. Now, it doesn't matter which one you choose to put the plus or the minus. It still give it the same. Go ahead, Ms. Clark.
That was going to be my question, sir.
All right.
But you answered it already.
Okay. All right, so everybody understand the process or the procedure in factorizing difference of squares? Let me see the hands of those who understand what we are doing.
Sir, I was writing that off.
Oh, you were writing?
Yes, sir.
Okay, I didn't know that you were writing, and I'm not sure if I can get it back. Oh, there it is. Are you through writing yet, Miss?
Yes, sir.
Okay. All right, so that would be the procedure. So you write your terms in their squared forms. Then you open two brackets, put the bases in them, and then put the plus or minus sign in between them in either bracket. Now looking at this second one here, now even though this is a bracketed expression, the entire expression is squared. So we're treating the entire expression as a single term. So it means that that bracketed expression is one square term minus the c square, which is another square term. So obviously we have a difference of square. Might not be very obvious to everybody, but if you think of all of what, if you just think of the entire bracket as a term, then this is the bracket square minus c square. And we are treating it just as though we treat any of the terms up here. So the first, we are going to put down the base being the bracketed expression. So we put down a minus b, and that would be the base of the brackets. Remember, the bracket is a minus b all square, and the base would be just what? A minus b. And so we're going to put the base, then the base of the c in one bracket. Then we're going to open another bracket and do the same thing. So we're going to put a minus b. And then we're going to put the base now of c. And then now we're going to put one we put a plus sign, and the other we put a minus sign. And now the inner brackets, because they don't have any number or terms in front of the bracket, we can just remove the inner brackets. So if we remove the inner bracket, we are left with A minus B plus C. And then for the next bracket, we have A minus B minus C. Let me see the hands if you understand that clearly, guys. All right. All right, so with that said, I don't want to have the time running out from last class. So this is another one here. And so this one may pose a little difference from the one that we did previously. Can you just try do this one quickly and let me just quickly walk through it with you? Just raise your hand when you're through doing it. All right, guys. All right, Ms. Cavero.
Yes, sir.
Quickly tell me what you get.
All right, so I got C plus open brackets.
All right. So you got C.
Yeah, and then plus, and then you open another bracket, and it's X minus Y.
And what else?
And then in another bracket, you have C minus, wait, then you have another bracket open, X minus Y. And then close bracket. And then in all, I got the bracket under it now. I got C plus X minus, C plus X minus Y. And then in the other bracket, I got C minus X minus Y.
All right, so this is where you got trick. So it is not actually C minus X minus Y, but rather C minus X plus Y. Can you see why?
No, sir.
Can anybody see why?
Two negative makes a positive.
Exactly. If you have a minus outside the bracket, you have to change the signs in the bracket. Remember that? Remember that, Ms. Cavero? So
Yes, sir.
this negative sign, because you're kind of treating it as -1, so -1 times X give you a negative X, -1 times negative Y give you a positive Y. All right?
Okay, sir.
Okay, so all right, don't let that catch you again. All right, good trial though, Miss Cabrera. All right, so with that said now, let us see if we can. So this is what it would have looked like. All right, what about this one now? Just write this one off. Don't do this one yet. I'm going to ask you to probably try that for homework. Just tell her if you want to just make a screenshot and then I can move on. Can I move on yet? All right, so I'm going to be moving on. All right, now, look at this one though. Let me write this. This one is 9 minus 36x squared. Let me write this one and ask you to do this one. 9 minus all right, can you try this one for me? 9 minus 36x squared. Factorize this and tell me what you get, guys. All right, just raise your hand when you're finished.